All right. My name is Eric. As a part of Group 1, we're going to go over Chapter 11, Enable and Practice Continuous Integration. The slides were put together by Jeremiah, and Devin and I are going to be doing the presentation. Next. With continuous integration, it's important to work out of a trunk more. We don't want to create so many branches so it's difficult to integrate back into the trunk and deploy. When you're creating branches prevents destabilization while developing and committing code. Isolation in the workplace creates problems with integration. Even increasing the amount of branches and chains becomes more of an issue. Integration can cause some problems, such as conflicting changes that need to be manually merged, merges that break the automated or manual tests, which requires multiple developers to successfully resolve. Longer time spent integrating forces, corners to be cut to make release dates. And when merging code is painful, it's done less often. It makes future merges worse. And then finally, making merges into the trunk as a part of everyone's daily work solves these problems. Story time. Gary Groover. Oh, yes. I can relate to the story, actually. So, Gary Groover's story is he was a director of engineering for HP's LaserJet firmware division, where they had 400 developers across US, Brazil, and India. And to make any changes, to deliver any new features, it was really slow. They could only complete 2 firmware releases per year. 5% of the time was spent coding new features, and then the rest of the time was either on detailed planning, porting code from various branches, integrating code from other branches, and even doing manual testing. That was the majority of the time. So they wanted to implement the following to increase development by 10%. As you can see on the slide here, you have continuous integration and truck-based development, which is basically working out of the trunk and continually committing to the trunk throughout your development each day. Significant investment in test automation, which means investing more time and resources like money into programs and resources to be able to create an automated system where you can test the code that's being developed. There's creation of a hardware simulator, so tests could be run on a virtual platform, kind of goes along with test automation. The production of test failures on developed workstations, and a new architecture to support running all printers off a common build and release. These were all implementations so they could increase development. So along with these goals, there was a new architecture suggested that would everyone work on on a common code base. So basically trunk-based development. 4 years later, one code base supported all 24 HP LaserJet production lines, and to work correctly, you needed to build effective automated testing. So with that, and Groover says, without automated testing, continuous integration is the fastest way to get a big pile of junk that never compiles or runs correctly. And that's true. So you have to continually commit your code to the trunk, but you also need some good testing, some automated testing, so that when it's broken, you know it's broken right away before you continue to develop on broken code. Another thing they did is they invested in 2,000 printer simulators to test firmware automatically and create a culture that halted all work anytime the development pipeline broke. And then, of course, they also created automated testing on every commit, and on final full integration testing, they accomplished the following. So you have you reduced the build to more than 1 per day. There was over 100 commits per day by individual developers. Now, currently I'm a developer, and to commit your code that frequently per day, it requires a lot of reminding, and to be able to accomplish that, they all had to be on the same page. They were also able to enable developers to change or add 75,000 to 100,000 lines of code each day. That's cumulative. That's not per person, because that's insane if it's per person. And they reduced regression test times to 1 day. They reduced regression times to 1 day. They focused on innovation and creating new features. That increased from 5% to 40%. Development costs were reduced by 40% because less time was spent on testing, less time was spent on integrating code from branches, porting code, fixing broken code. There were a lot of costs reduced by that. Programs under development increased by 140%, and development costs per program decreased by 78%.
Small batches and commit to code trunk. Branch strategies summed up are: you need to optimize for individual productivity and optimize for team productivity. Effort to successfully merge branches increases exponentially as the number of branches increases. The problem lies within merging branches as well as integration testing, which would likely happen at the end of the process. Increasing code production increases the chances of affecting someone else. And it's difficult to merge results in individuals being unmotivated to improve or refactor code. Likely to cause rework for everyone, or this is likely to cause rework for everyone, and people are more reluctant to modify code that has dependencies.
I found where that was, by the way. It started on the second dark bullet point, and optimized for individual, or the bullet point sub to that. So that's where it is. Anyways, continue.
Yep. Now we're on adopt trunk-based development. This is when developers check in their code to the trunk at least once per day. Automated tests are more easily done on the whole system, and problems are caught earlier and more easily resolved when this is done. Gated commits prevent any commits that change code or the environment that takes the system out of a deployable state. This breaks down work into smaller chunks while keeping the trunk in a working releasable state. Everybody can help everybody else when it breaks, and it results in a higher quality and faster deployment lead times, adding to what is done. We have integrated, tested, working, and potentially shippable code demonstrated in a production-like environment, created from a trunk using a one-click process and validated with automated tests. This eliminates having a separate test and a stabilization phase at the end of the project. Story time once again. This is from Bizarre Voice in 2012, and after using Agile, the company fell into chaos, attempting 2-week releases. Mueller took over and observed that no test automation was in place to prevent large-scale failures, and no version control branching strategy was put in place, and the teams were running microservers where all performing independency releases which were causing issues. They took 6 weeks out of their schedule to write automatic testing suites. They started using the trunk branch release model, and after just 3 cycles, it was normal to be able to release on time with no customer incidents. When they did release initially, it ended up causing, let's see, I thought I had a statistic here. Maybe I didn't. It's okay. I'll cut it out. So, in conclusion, according to Puppet Labs 2015 State of DevOps report, trunk-based development predicts higher throughput, better stability, higher job satisfaction, and lower rates of burnout. Continuous integration practices set the stage for the next step, which is automating the deployment process and enabling low-risk releases. Yay! I don't think it be how it is, but it do.
Good old Chong.
Yep, good old Chong.
I love it.
Yep.